Welcome to my channel Maitri SK. In this session, we are going to see the second half Principles of Amplitude Modulation System. This is where the actual syllabus Amplitude Modulation starts here. When starting with the Amplitude Modulation, we need to know what is communication system. So, we are going to see or start with Introduction to Communication System, followed by amplitude modulation, its types, then representation of its AM signal, then generation and deduction of the same. What is communication? So to start with, we will start what is communication. Communication is nothing but the process of conveying an information from one point to another. So what we are doing now is communication. That is, I am conveying the information about the subject 3491 communication systems through this medium. That is, I am in one place and you are in another place. That is, I am the source and you are all the destination. So this is the purpose of communication system, that is to communicate an information bearing signals from the source located at one end to the user located at the other end. So the three most common source of information includes that is audio, video and data. So now what I am speaking, that is analog format. It is an audio signal which is simply known as speech or sound signal. Then video signals, when we are making video calls you can relate with it, and data signals when we are sending messages, text informations or WhatsApp informations, that is all bearing text bearing informations in alphanumeric characters. So regardless of the source, the information that is transmitted and received in a communication system consists of a signal, encoded information in an appropriate fashion. So this is what a communication is. So coming to the block diagram representation of the same, a simple communication system has the following. So that is, three informations are very important here. You could see, that is the information bearing signals with respect to, right? So the information or data from the transmitter end is given to the receiver end. That is, this is an one point and this is the other point. So in between we need to communicate through a device, or that is the channel. Here the channel is nothing but the air. Medium here is air. So basically a communication system consists of an input. So you could see here the word system, how it is related. Now the system which has an input in the format of information source and output in the format of again the same information source which is given here to the user. So in between, this communication system has devices which facilitate this communication of information source. That is, it consists of a transmitter and a channel through a receiver. That is, end is the receiver. So if it is through a medium called air, so air consists of, is a common channel where most of the informations are being transmitted. So here not only one signal, that is whatever I am talking now is not being transmitted through the channel, but there are n number of signals which is contained in this channel. So we'll see the effective form of information which is to be received by user is a very important, and that particular area has more research possibilities to identify the best signal for the receiver or the user end, right? So this is a basic block of a communication system which consists of a transmitter, channel and a receiver. So when we are talking about the channel, which is a common medium, this noise factor is very important, as I have said in the introduction class. You could recall in the format of signal to noise ratio I said, and the best example I gave in the format of usage of fan in our class. If I am taking an offline class, how I related a fan. So the noise is present in the environment. this noise is to be reduced. That is very, very important when an information is passed. So what will be the output here is y of t should be equal to x of t, but when we are talking about this kind of signal, this will be x of t plus the noise signal n of t. So generally a communication system output is represented by this equation. So this is what the basic block diagram has. Next is modulation. When we are talking about a communication that is from a transmitting end to the receiving end, this transmitting to receiving end is easier when it is a line of sight communication, right? So when two people are being conversed in a short distance, when it is an offline class example, I can converse to you in my audible frequency range of 20 hertz to 20 kilohertz without any device. But when it is a long distance communication, that is, if I am sitting in one place, example, I am sitting in Coimbatore in a different area, and you people are sitting in a different area. Some people are in hostel, some people are in class, etc. So you could see here this information which is carried through the medium called channel to you. So how this is convened means by means of using particular systems which is convene this system. So what is that is it involves a modulator. So what is modulation is very, very important. That's what we are going to see about modulation here. What is modulation is nothing but we are going to convert the signal what is given in the transmitter end to the receiver end at a long distance in a specified format. That is, the message signal is to be converted and carried through this medium in a different format, and it is to be received at the receiver end. So modulation is performed at the transmitting end of a communication system. So modulation always prefer to do it in the first half, the transmitting end. And in the receiver end, we want to recover the original signal what is being transmitted. That is demodulation occurs at the receiver end. So at the receiving end of the system, we usually require the original, that is the baseband signal. Original signal is also called as the baseband signal, which is to be restored. And this is done by process called as demodulation, which is the reverse process of modulation. So in basic signal processing terms, we thus find that the transmitter of an analog communication system consists of a modulator. So as I said, at the transmitter end, transmitter section has the modulator and the receiver section has the demodulator. So now when we are defining about the modulation again, as I said, in a line of sight communication which has a 20 hertz to 20 kilohertz doesn't need any device to be carried my information to you. Just I am speaking and you are all hearing. But when it is a long distance communication, my message signal, that is whatever I am speaking now in a frequency range of 20 hertz to 20 kilohertz, which is an analog format, is a less frequency or a low frequency to be carried through this channel called air. That is, when we are talking about long distance communication, this channel is referred as electromagnetic spectrum. So this electromagnetic spectrum carries the frequency which is very, very highest frequency. So this signal is to be taken, the message signal is to be taken or carried by a different signal frequency which is much higher than that of the message signal. So here we must know about, when we are talking about modulation, it involves with a message signal frequency which is the low frequency signal and a frequency signal which is used to carry this message signal, that is called as carrier signal, which is a high frequency signal. So here three signals are very, very important when defining a modulation, that is message signal, carrier signal and the modulated signal. So now defining this process. So what is modulation is nothing but we are going to change this message signal format into some other required format which is carried through this channel with respect to one signal, right? So we have, how it is done is by means of the process called modulation. So now defining it technically, modulation is the process by which the characteristics of the carrier wave, that is the wave which is used to take this message signal, is instantaneously varied with respect to the message signal. So we are going to change this process with respect to the information signal only, right? So the any signal, when we are talking about a signal, the signal will be in the format of a sinusoidal format, that is a sine wave or a cosine wave. This sine wave, when talking about, it is dependent on the time characteristics. As we have seen in the introduction class about the signals, the signal can be represented in terms of amplitude, frequency or phase. This characteristics is nothing but it is talking about this amplitude, frequency or phase of the signal. Thus the modulation is also defined in terms of amplitude, frequency and phase. So as I have mentioned, the three types of signals involved in modulation process, that is the message signal or modulating signal, and the carrier signal, and the modulated signal which is followed at the output. So in the modulator, that is modulation is very important. So this is happening at the transmitter section and this is happening at the receiver section. That is a modulator which consists of a message signal, which is the input signal having a low frequency signal, and a sinusoidal carrier signal which is having a high frequency signal. This is given to the modulator and it produces the modulated output. So and the demodulated output, the input or the output obtained from the modulated wave is given as input to the demodulator, and finally we will be getting the message signal which is already sent here. So this is what the modulation happens. Okay, we are all talking about modulation, but what is the importance of modulation or need for modulation or requirement of modulation? There are different terminologies or words used, but the meaning is same. Why we go for modulation, right? So if modulation is not employed in a system, what happens here is it may end up with a different types of problems. So in order to avoid that, we go for this modulation. The first advantage of using modulation is to ease the transmission by enabling the antenna height. So when talking about antenna height, I'll come to it later. Then comes the multiplexing, then to reduce noise and interference, and to enable narrow bandwidth, and for frequency assignment, finally to overcome or reduce the equipment limitations. So as we are talking about modulation, as I said, it involves with the transmitter end and at the receiver end. So when we are talking about the transmitter, we'll be dealing with the antennas. So when designing an antenna, you could have seen in the real world scenario different set of antennas employed at different locations. What is that antenna implies you, or what you have understood from that antenna is nothing but all your mobile communications or whatever the broadband communications, satellite communications, everything happens through this antenna only. Why that particular antenna? Do you feel this whole setup is a communication device? No, not at all. If you look into the antenna, at the top end there will be some devices which acts, that is called as the antenna, which is employed at the top of the mount. This is actually the mount you are all seeing in steel, huge steel structures. Okay, so if this huge steel structure, this height is very important. This height is very important. So when we erect this antenna height, if a huge number or large number of height is involved in designing, what happens here is the maintenance cost will be more, the equipment charges will be more, and etc. It involves in many sort of discomforts. So in order to reduce the antenna height, this modulation will be helpful. Okay, so to reduce the antenna height, this modulation technique will be very helpful in case of relating it with the band wavelength, that is lambda, with respect to the antenna height. Next, talking about multiplexing. So since the channel is common, as I said, not only myself communicating to this through this channel, many other signals are being present in this channel, and many around the world is communicating. So this common channel multiplexing is nothing but 2 power n number of inputs is taken, and it is given, that is 8 inputs to 3 outputs can be taken, or 3 means 2 power n, right? 2 power 3, that is 8. So all these, if we are considering only 3, so we can say that it is multiplexed with respect to 8 channels. So through 8 medium, we are going to transmit the same signal over the channel, that is enabled by means of modulation to reduce noise and interferences. So when we are talking about this modulation techniques, this effectively reduces noise and interferences. And for narrowing the bandwidth also, it's very important. So narrowing bandwidth means instead of allocating a signal over a wide capacity, we can allocate the same signal in a smaller bandwidth or space. So that is very important and easier when go for modulation. So the same is involved for frequency assignment. So as I said, my set of signal frequency transmitted through the channel will be represented as f1, and another set of signal which is transmitted will be f2, and another set of signal which is transmitted will be f3 hertz. So there are different set of frequency assignment for each of the signals which is transmitted when we go for modulation. Next, as I said, when we are erecting, and not only with the antenna height, in order to reduce the equipment limitations, this modulation plays a major role. So it is a very important 2 marks, and it is this antenna height is very important in case of practical scenarios when you are involved with the transmission and the reception of a signal. Right. So what are the types of modulation? Now, talking about the types of modulation, modulation is divided in terms of with respect to the nature of the signal. It may be a continuous wave modulation, or it may be a digital or discrete modulation. So in earlier signals and systems, you might have studied about CT as well as DT. Here, instead of DT, you will be noting that signal as pulse. That is digital modulation only, but it in terms of pulses. There you might have noted in terms of samples, this samples is represented here as pulses or strokes. So continuous wave modulation is further divided into 2 cases. One is amplitude modulation and another one is angle modulation. What is angle modulation is further it is divided in terms of frequency modulation and phase modulation. What about pulse modulation? Pulse modulation is divided into 2 again, digital modulation as well as analog modulation. And again further this digital modulation is purely divided into terms called pulse code modulation technique, whereas analog modulation is further classified with respect to, here both analog as well as digital plays a major role with respect to pulse amplitude modulation, pulse duration modulation and pulse position modulation. Now as of this modulation technique is considered, for unit 1 we are going to concentrate only with the continuous wave modulation. This both together both is called as amplitude modulation, that is analog modulation. This amplitude modulation is explained, and this angle modulation is explained with respect to the same signal. So as we know, the sinusoidal signal is being carried in last class itself, first chapter itself I have explained about this. So this, when the wave is varied with respect to height, that is voltage level, that is called as amplitude modulation. When there is change in amplitude, it is called as amplitude modulation. When there is change in frequency, it is called as frequency modulation. When there is a change in phase, that is instead of 0 it starts with 1, or 1 it starts with 0, you could see here this occurs with respect to a shift in frequency, whether it can be 90 degree or 180 degree or 270 degree or 360 degree phase shift. that is called as phase modulation. So here, yeah, diagrammatically this is explained here. You could see here the height of the signal is being varied with respect to amplitude modulation. So when talking about a definition format, so instead of this modulation definition, you could just replace the characteristics here. Which is changed here is the amplitude. That's why it is defined like this. Amplitude modulation is the process by which the amplitude of the signal, that is, the carrier wave signal, is instantaneously varied with respect to the message signal. So when we are giving into the amplitude modulator, the modulating signal and the carrier signal, we will be getting a amplitude modulated, that is amplitude modulated signal at the output. So you could see here the carrier signal is having the highest frequency and the message signal is having the lowest frequency. So similarly, we are talking about the frequency modulation. So here, with respect to the diagram, you could see here the carrier and the message signal are same. Whereas for the negative region, you could see here there is no change in the amplitude or height level. Whereas the frequency here is much closer, which says it has a lowest time duration is here very less, so the frequency component is higher. So here also the same, for the negative it is changing, so it is varying with respect to frequency. So we can say the frequency modulation is a process by which the frequency of the carrier wave is instantaneously varied with respect to the message signal. Next, it is about the phase, as I was trying to plot this. So now it is clearly visible how the message signal is varied in terms of phase. So it starts with the same signal with the phase shift where it stops or the zero phase occurs, right? So it is having a phase shift here, again it is having a phase shift over here. So you could simply in phase signal changes, you could see a signal type having a W or an M symbol which is occurring at the changes. If there is a change like parameter which is having a modulation instead of a continuous flow of diagram, if there is a if there is a signal which is drawn like this, so it stops here, again it goes like this, right? So you could see here W or M type of signals occurs when we are talking about the phase modulation, and the definition is same where the characteristics here is replaced by the phase. So now coming to the types of modulation. What are the types of modulation here? Types of modulation involves with here the double sideband. So simply amplitude modulation itself is called as double sideband full carrier AM. Next is double sideband suppressed carrier AM, that is DSB SEAM, or single sideband suppressed carrier AM, that is SSB SEAM, and vestigial sideband AM. So each and everything will be explained separately with respect to generation as well as its deduction technique. Now we'll start with simply the AM modulation technique, and it generators includes two types. When talking about the generator part, that is square law modulator and switching modulator is its type, whereas in demodulator part it involves with square law modulator and simply an envelope detector. This you will be seeing in the lab also. So now coming to the mathematical representation of AM. This is a very important 15 or a 13 mark derivation part when considered for the university question paper or final exam question paper. As we know, the signal, when we are talking about modulation, it involves two set of signals, that is message signal or the modulating signal and the carrier signal. So when talking about message signal, which is a continuous time format, I am considering this message signal as an equation format which we have studied in SS. As you know, it can be represented in terms of sine omega t or cos omega t. Since we are having an amplitude change, I am using it here A. Sometimes in some other representation or book, it can be represented as V. V is also a voltage. A is also called as an voltage or amplitude, right? So it is sine omega t or V cos omega t can be used. So the terminologies can be different referring to different books, but the concept is same. Please do understand. So the message signal is represented as m of t equal to amplitude of the message signal am into cos omega mt. So cos omega mt is here represented here. Omega is nothing but 2 pi f. Since we are using message signal m, so here also omega 2 pi fmt. Similarly, for carrier signal, c of t is vc cos omega ct. So you know what is AM, AC, I have said clearly it is about the message signal or carrier signal. That's what is explained. And what is FM is nothing but message signal frequency as well as carrier signal frequency. So when we are solving this equation, we'll be getting by using trigonometric solution finally, and based on the definitions, this amplitude modulated wave can be simply represented as the output signal, that is, you can also represent this as output v of t equal to vc plus vm cos omega, that mt, into cos omega ct. So when we are representing this kind of signal, you could take Vc outside now. So, right. So when taking Vc outside, the same equation, rewrite it. So taking Vc outside, here it will be 1 plus Vm by Vc into cos omega mt, and already we have outside cos omega ct. So here instead of Vm by Vc, I am going to use a new terminology or format called as mu m. That is, mu is nothing but the modulation index, which is simply represented as ma. So it can also be represented as ma. So modulation index is the term which is represented with respect to the ratio of Vm by Vc. So the same equation here I have rewritten, that is, instead of S of t I have written V of t, that's it. So taking Vc outside, when solving this equation, we will be getting Vc into 1 plus mu into cos of omega mt into cos of omega ct. So what is this mu term is nothing but the new term we have arrived for the amplitude modulation, that is modulation index. Simply it is also called as Vm by Vc. So here solving this equation, final equation consists of, so actually the steps here are, so we could see here after this equation number 1, it is Vc into 1 plus mu into cos omega mt into cos omega ct, you could see. So this cos omega ct is common for this signal also, right? So when multiplying this, it becomes Vc into cos omega ct. This cos omega ct is common. So again it is Vc into mu here, mu into cos omega ct into cos omega mt. So here these are the terms we have arrived, and you could see here this cos omega ct and cos omega mt is of the form cos a cos b. So you know the trigonometric solution has a formula. Cos a cos b is nothing but 1 by 2 of cos of a minus b plus cos of a plus b. So here I am using a value as omega c. Always consider carrier which is having the highest frequency is to be uh, taken as a. And what is your b term? It is omega m. So now merely substituting it in this equation, we will get S of t or out v of t is nothing but Vc into cos omega ct plus mu into Vc. Here by means of using this formula, it becomes 1 by 2. I am taking this 2 outside. This is cos of omega c minus omega m into t plus cos of omega c plus omega m into t. Are you clear? So here we could see here, this is the final equation which is to be represented or used. So representing this equation, we could finalize here. There are three terms present at the output of an amplitude modulated signal. So let me take, this is the first term, and this is the second term, and this is the third term. So what is this first term is nothing but which has only Vc and omega c, that is nothing but the carrier. And the second term is nothing but which is having minus term with respect to omega c. So it is called as lower sideband or LSB. And with respect to omega c plus omega m, it has plus sign, so it is the upper sideband. So we can say an amplitude modulated signal has three component, which is called as carrier, lower sideband, and third one upper sideband. This is very important terminologies when you are studying about amplitude modulated signal, because the next upcoming topic of DSB SSB is dependent on this suppression of this sidebands with respect to this amplitude modulation and how it is advantageous when we are moving to the further amplitude modulation techniques. So please do remember this. So this is the final equation when we are talking about the amplitude modulation mathematical equation. So it has three terms. So just recall, this carrier, lower sideband and upper sideband. So how this can be denoted here is that spectrum is missing. So I will draw the spectrum here, then we will move on to the next modulation index. So for this three terms, how this amplitude modulated spectrum is drawn is shown here. So how we can draw this spectrum here is, consider spectrum is nothing but representation in terms of frequency domain. So as I said, carrier is very important. We can say this as the FC part with respect to zero signal, and here you are going to represent omega m part. So omega m, that is nothing but which consists of the frequency terminology Fm, and here the negative half you have your minus omega m, that is minus Fm. So here what is the signal contained within this duration is nothing but Fc plus Fm, or it is simply omega c plus omega m. So this is your upper sideband and this is your carrier, that is Vc, and this is your lower sideband, which is nothing but with respect to omega c, it is omega c minus omega m. So this is what the spectrum represents. Just draw two heads in the spectrum column, which shows the representation of signal. So this is your spectrum, right? Carrier, lower sideband, upper sideband. So what is your bandwidth is nothing but the duration where the signal is contained is called the bandwidth. So it is nothing but duration between these two. Yes. Now coming to the modulation index part. So a carrier wave which is after being modulated, and the level or the depth in which the carrier is modulated is being given by means of this modulation index. So that is called as modulation index or modulation depth. So how much level of carrier is being modulated is explained by means of modulation index. So simply it states the level of modulation that a carrier wave undergoes. So when talking about modulation index, it is also represented as MA in terms of amplitude modulation index, AM modulation index. Simply it is the given by ratio of Vm by Vc. That is, Vm is nothing but voltage of the message signal to the ratio of carrier of the message signal. It is also represented in terms of Vmax minus V minimum divided by Vmax plus V minimum with respect to the amplitude modulated signal given as the output case when different types of signals are taken. So this is the amplitude modulated signal when we are talking about with this is being the V max situation, this being V minimum situation. So when we are substituting for Vm and Vc and solving it, you will get the equation of V max minus V minimum plus V max plus V minimum. So this is the modulation index has two equation format with respect to message voltage as well as with respect to minima and maximum voltage. So often this modulation index is denoted in terms of percentage of modulation. That is nothing but after getting this modulation index by substituting this value, simply multiply it by 100 to produce a percentage modulation. So now talking about the modulation index as we said, it is dependent on the carrier wave, how depth it is being modulated is explained here. So always when Vm is equal to Vc, it has 100% modulation. Are you clear? So the previous equation I said, just by multiplying it with 100 we will get a percentage modulation. So when Vm by Vc is equal to 1, what it implies is Vm and Vc are same. Vm is equal to Vc. So after getting this, just multiplying it by 100, it gets 100 percentage. That is, Ma becomes 100 percentage when Vm by Vc is equivalent to 1. So this value is very important, and here this condition here when it arrives at 100% is called as a critical wave, which is equivalent. Whereas it has two other cases, either it can be less than 1 or greater than 1. So when it is less than 1, it is called as undermodulated wave, and the waveform will be shown or represented or arrived like this. When it is greater than 1, that is if it is occurring with 1.5 or say and some other value which is greater than 1, it is called as overmodulated, where a signal which is actually amplitude modulated, a small hype of amplitude modulated signal will also occurs. So this is what is called as degrees of modulation. This is called as degrees of modulation. So when we are talking about the 2 mark question, what are the degrees of modulation? You must mention first one under modulated, over modulated, and third one critical modulation. Right, and the condition is very important. So now coming about the bandwidth calculation, as we have seen with respect to spectrum, as I have shown here with respect to Fc, it can be Fc plus Fm, and here it is minus Fc, that is minus Fm. So when calculating this is giving the bandwidth. So we know what is this half is nothing but upper sideband is nothing but that is generally speaking bandwidth is nothing but maximum frequency subtracting the minimum frequency. Here the maximum frequency will be the right hand side, that is the upper sideband frequency minus the lower sideband frequency. What is the upper sideband frequency is Fc plus Fm. What is the lower sideband frequency is Fc minus Fm. When substituting these value here, you will be getting Fc plus Fm minus Fc minus Fm. So here minus Fc, here the term FC gets cancelled. Minus of minus becomes plus. So you will get twice that of the message signal frequency only. So here simply the representation itself shows here FM and here also one FM. Both added together it produces 2 FM. So always the bandwidth required for amplitude modulated signal will be twice the frequency of the message signal. It's also very important, 2 marks. Then comes the AM power calculation. So considering an AM power calculation, we need to take the signal contained with carrier. This is the first term. This is the upper sideband and this is the lower sideband equation. So always the power is contained with respect to these three terms, that is carrier power, upper sideband power and the lower sideband power. So adding together all these gives the total power. So we know the standard formula for the power of the cosine signal can be given as in terms of root mean square value, that is power is equal to V square by R. In terms of V RMS square, this can be represented by Vm by square root of 2 the whole square by 2. So what is VRMS is nothing but RMS value of the cos signal, and Vm is nothing but the peak value of the cos signal. So when solving this signal, you will be getting p value of Vm by square root of 2 the whole square becomes 2 itself, that is Vm by 4. So now before substituting it, we'll go in another way. So let us find the power of the signal in terms of carrier power, upper sideband power and lower sideband power, and finally adding all these together, we'll be getting the total power PT. So when substituting it for PC is nothing but in terms of V square by R, it is nothing but Vc by square root of 2 the whole square by R. So when solving it, it becomes Vc by square root of 2 the whole square is by 2 itself. So here it is AC by square root of 2 the whole square means it is AC square divided by 2. So already here R is present. So it is AC square by 2R. Next comes the upper sideband power. Similarly, since the carrier power is something which is represented in terms of a Vc by square root, only it contains a carrier alone. That is the equation you could see here why this is represented. Since the voltage represented with carrier is only AC, we are considering only the power in terms of AC or Vc. Whereas in terms of upper sideband or lower sideband power, you could see here both the upper sideband and lower sideband has a common factor of Vc into mu by 2. So that term is very important, and that term is only taken and replaced instead of this V. So it is Vc mu by 2 divided by square root of 2 the whole square. So solving it, you will be getting AC square mu square or MA square divided by 8 into R. So you can also use mu instead MA in some other books, or myself in some other videos I have given this mu as MA representation only. So don't get confused, both are same. So it is AC square or VC square into mu square divided by 8R. So you could see here both the terms of upper sideband and lower sideband terminologies are same. You need not derive it again. It is the same or equivalent to the upper sideband specification of power only. So substituting all these power calculations. So what is PC? What is PLSP? What is PUSP? Just add it. So we are going to add this PC with respect to PLSB plus PUSB. We will be getting the total power, that is VC square by 2R plus VC square into mu square by 8R plus Vc square mu square by 8R. Sorry, I'm used to V, that's why I'm using mu. Since in here I have used A, I'll go with A itself. So here you could see here AC square by 2R is common to all. Take it outside, it will be 1 plus, here you can represent this as twice that of AC square by mu square by 8R. Simply it will become AC square mu square by 4R. So already we have taken AC square outside. So it will be mu c square by 2. Already 2R is outside. So this is the final thing we have arrived. So let us see the calculation. Yeah. So the calculation here is same. So what we have done, it is same. So simply now replacing this Vc square or AC square by 2R with carrier power. So finally the total power is given in terms of PC with respect to modulation index, that is mu square divided by 2. So for 100% of modulation index, what will be your carrier or total power is one of the question if you understand the concept. So when we are talking about 100% modulation index, mu will be equivalent to 1. So substituting it 1, it will be Pc into 1 plus 1 divided by 2, that is Pc into 3 by 2. Am I right? So 3 by 2 it will be 0.5. 1.5, yeah, 1.5. So what is your PT here is 1.5 of PC. So this is the calculation of power equations. Next topic, what we are going to see here is with respect to AM generation. So let us discuss about the modulators which generate this amplitude modulated wave. So what are the two modulators used to generate AM wave here is the square law modulator and the switching modulator. So first looking into the square law modulator, it involves a non-linear device. A non-linear device is nothing but it can be a diode or a transistor. So involving it, it consists of three components. One is the summer, another one is that is summer is nothing but the adder, which has a square law device or a non-linear device, and a filter. There are three components used for a square law modulator. So just giving a message signal and a carrier signal to a summer, it produces an output, and it is given to the diode or device or a transistor device which produces an output of an amplitude modulated wave. When passed through the filter, the unwanted signal which is produced along with the modulated wave is surpassed. That is, it is filtered and give the final AM signal. This is the concept here. So this is what is explained mathematically here. When two signals are given to the input, so message signal I am giving and I am writing it as message signal along with the carrier signal. So what will be the output at the V1 and V2 is shown here. So V1 of t is nothing but we are taking a message signal along with the carrier signal, and V2 of t is nothing but which is dependent on the characteristics of diode, and it is based on the square law. So, hence it is called as a square law modulator. So it is dependent on a K1 into V1 of t, this is V1 of t, plus K2 into V1 square of t, and it goes on. So since it is a square law modulator, we stopped only with the square equation. So solving the above equation, so you could see here, solving the above equation by substituting V1 of t over here, you will be getting the huge equation over here, K1 into this term is V1 of t term, and this 2 is also the V1 of t term. So here, since square law modulator is used, this term is stopped with square function alone. So solving it with the formula a plus b the whole square, and arriving at a equation, we will get a huge term, that is k1 m of t. This term is the same, whereas this term it is squared term, that is using the formula a plus b the whole square formula and solving it for 2ab. A here is m of t, b here is cos of, that is ac into cos of omega ct. We will get this term, so squared term and 2 times that of ab. So now this is the equation we are getting. So we want only the three terms for the AM modulated signal. So here we are passing the signal through the low pass filter. So passing the above signal, the filter band pass filter rejects the squared term and it gives only the signal which is amplitude modulated wave. So comparing this with the amplitude modulated standard signal waveform, so it gives the carrier along with the message signal which is contained with omega c, and there is omega m and omega c. Hence we have the three terms of carrier, lower sideband and upper sideband. So hence we have produced the AM signal by means of using square law modulator. So now coming to the switching modulator. So how the switching modulator is working. So switching modulator is also a similar device to that of a square law modulator, but the only difference with respect to square law modulator here, the diode will be operated in a non-linear mode. Non-linear mode means the output is not dependent on the input scaling factor, and it can take any value with respect to input. So it is called as the switching modulator. Switching means it switches from a low level to high level or high level to low level. The same concept of message signal and the carrier signal is given to the summer, and it is producing an output Vm of t. So finally the unwanted signal which is produced at the diode output is now giving the amplitude modulated signal. This is the same concept of the diode modulation, that is previous square law modulation. So here also we are explaining with respect to the diode condition. Since you are using a nonlinear device as the diode, so both the message signal M of t and the carrier signal is given to the adder. So it produces an output V1 of t that is given to the input of the diode. So the assuming the magnitude of the modulating signal is very small, now we are going to see the operation of the diode states. So when the diodes on and off action will be controlled by means of this carrier signal C of t. So we can say the diode will be either in a forward biased or in the reverse biased. When it is forward biased, the diode will be forward biased under the condition when it is greater than 0, and it will be reverse biased when it is less than 0. And therefore the diode output can be given in terms of V1 of t, which is happening with respect to the carrier signal, either it is greater than or less than 0. So now we can approximate this with respect to V2 of t as V1 of t dependent on the input x of t. What is x of t? Is nothing but the periodic pulse train with respect to time period ranging for 1 second. Right. So consider the periodic pulse train here. Example. So Fourier series representation of this periodic pulse train is, we know the Fourier series representation. So general equation format or whatever the equation format, just consider only the output. Just representation of a pulse train is nothing but 1 by 2 plus 2 by pi into cos omega ct minus 2 by 3 by cos of 6 pi, etc. So now substituting this as your input x of t, that is periodic pulse train in equation 2, will be getting this equation. Right, substituting here instead of this x of t, that is the periodic pulse train, we are getting this equation. Now solving it, just write the same. Now multiply this with respect to 1 by 2, again the second term, again the third term, we are getting the highest term. So now we are getting more terms apart from carrier, lower sideband and upper sideband. So we need to eliminate the unwanted signals or undesired AM signals to get the desired AM signals. So we are passing it through the bandpass filter to eliminate the remaining terms and obtain only the three terms which shows it is an AM signal. So it should have carrier, lower sideband, upper sideband. Hence this is the concept of switching modulator. Finally, where after passing it through the bandpass filter arrived with the carrier, and when multiplied with omega mt, we will be getting an upper sideband and lower sideband equation. So comparing this with AM, it is understood we have generated again an AM wave with respect to a switching modulator. Now generation part is over. So now we have generated an amplitude modulated wave. Now we want to detect or demodulate the same to get the message signal at the receiver end. So now this AM deduction is being happening at the receiver end. So it is nothing but the reverse process of modulation. So in demodulation, to enhance this demodulation, the device or circuit which is used to demodulate is called as demodulator. The demodulators used for AM demodulation is square law demodulator and envelope detector. So here it should be defined as demodulators. So square law demodulator, since we are using square law modulation, we are reversing the process with square law demodulator and envelope detector. So you will be seeing this envelope detector in lab session also. So square law demodulator is a very simple device which has a square law device where an input will be an AM wave, that is an amplitude modulated wave, right, changed with amplitude, is given as input, and finally when passed to the low pass filter it eliminates the unwanted or undesired signal surpassing the sidebands to produce only the message signal, that is the demodulated output. So considering an AM detection wave mathematically how it is obtained, considering a signal V1 of t, we are applying it to the demodulator, so which is nothing but having the upper side band carrier and the lower side band. So mathematically, if this two input is given to a square law device, based on the square law equation, it is represented with respect to a constant term k1 into v1 of t plus k2 into v1 square of t. So square law, so we are stopping only with squared function. So now substituting this v1 term here, will be solving it to get the output. So finally, you could see here more number of terms are present. Similarly, as we have obtained in generation part, the same equation is passed through the low pass filter where the extracted signal or DC component or everything is eliminated to obtain only the message signal or the modulated signal. The same process is followed for envelope detection. So envelope detection is used to detect high level AM modulation waves. So in lab setup, we'll be using this envelope detectors, which is using a diode as a device to convert this AM modulated wave passing through a low pass filter to produce the message signal. The same concept of equation is applied here and compared with the standard AM wave, and finally when it is passed through this low pass filter, so the signal containing carrier lower sideband and upper sideband is passed through low pass filter to give the extracted signal or the message signal as the output. So how this is enhanced is based on the diode conductivity over the positive half cycle and the negative half cycle, based on the forward bias and reverse bias conditions. The capacitor connected across it where it is charging and discharging the component and produces the output or the as a AM envelope. So this is what AM demodulation is. Hope I have given a brief description about all the AM modulation techniques, starting with communication till AM demodulation or detection part. So this is the key takeaway for today's topic. So we have studied about communication system enabling the transfer of information from a sender to a receiver over the medium, that is the channel. And the modulation key component here we are using is message signal, which is a low frequency signal, and a carrier signal with a high frequency signal. And next key component we have studied here is the carrier signal. Carrier wave has the highest frequency as I have mentioned earlier, and a low frequency for message signal. So AM wave is a key analog modulation technique used to transmit audio, video and other data over long distances. This is the earliest and a basic modulation technique which is used at the starting level of modulation part enhanced. So only we are now also studying this basic modulation technique, though nowadays we are using different modulation part. OFDM has come into picture, MSK, QAM techniques, everything has arrived, but this AM is a like a ABCD or an alphabet which you have learned in LKG. So this is a very basic technique. You need to know about the basics to know understand the better component of the technological advancement happening today. Next is we have studied about the AM bandwidth modulation index in case of 2 V max and V minimum with respect to VM and V minimum also. Next, degrees of modulation, and power calculation. Finally, I touch up with AM generation techniques. Two techniques are explained with respect to square law and switching modulator, and AM deduction or demodulation. Again, two methods with respect to square law deduction and uh, envelope deduction is explained over here. So, what are the questions which is possible in this today's topic here is they can be asking in part A, that is 2 marks, generally about the basic block diagram of a communication system. What is the need for modulation? Define modulation or simply amplitude modulation, and what are the types of AM modulation, and what are the types of AM detectors, what are the types of AM generators, and define modulation index. Sometimes specifically define modulation index in terms of maximum and minimum voltage, and what are the degrees of modulation, define bandwidth of AM, draw the spectrum of AM, and state the reason for calling envelope detector as a diode detector, etc. And part B possible questions. Problems in AM to find the bandwidth power modulation index can be asked, and problems in AM to find the lower sideband, upper sideband, and carrier given the voltage level. VM and VC will be given, so it will be easier to calculate the same. And derivation of mathematical representation of AM, and sometimes derivation of power calculation. Simply, it's the same question asking about the generation and reduction of AM. So problems maybe in part A, they can be asking only about the bandwidth calculation for 2 marks, or sometimes only the modulation index calculation for 2 marks. So hope you have understood the today's topic. We have started with the principles of amplitude modulation and the basics of communication, and ended with AM generation and reduction techniques. Thanks for watching.